In this tutorial we will see basic manipulation of Grand Designer and how to create a first planet with just a simple relief. So you can move around the planet by just dragging it with the left button. With the right button you can move it around, and if you click on the background you can move the background and the light at the same time. You have different tabs here. The main one is the planet, then you have the background where you have access to all the parameters of the background, and then the special effects where you have all the post effect like the bloom and so on. So we will go back to the planet, and for the planet we have several sub-tabs where we have all the parameters concerning the global things, the relief, details, craters and so on. We will see today how to use the global and relief parameters, and so how to create a basic planet. With the global settings you can basically move around in the 3D noise. You have to see that as a big block of random matter, and you can move around your planet in this block. So with the translation you're basically moving alongside X, Y and Z axis. For every slider you can always press the R button to reset it to its default value. Then you have the rotation, so it's not the planet which is rotating, even if it looks like that. It's just the noise which is rotating around the planet. So you can rotate around X, Y and Z axis, and then you can scale the noise on the X, Y and Z axis. So you are stretching the noise around the planet. Then you have something quite interesting. It's still experimental, but it's working quite well. It's the coverage. So you can basically edit just a partial planet, not a full planet. With this slider you choose the percentage of the planet you want to edit. So by default it's 100%, and if you reduce it you see that you have just a portion of the planet that you are editing. What is interesting here is that that portion of the planet use the same size, the texture of the same size as the full planet. So you have much more details for a reduced area. So you can really have lots of small things going on here, where when you edit a large planet everything is much softer, because by default you have less pixel considering the size of the object. So when you have a smaller area you can change also the flattening. So if you want to have a flat terrain, then you can use that, or you can have slightly curved one. It's really up to you. You can also move around the planet, so you can choose which portion of the planet you want to edit with the latitude and longitude offset. It's better not to move away from the equator with the latitude offset, because if you go to the pole you will have very stretched texture. So you see it's not a square anymore, it's just a portion of the planet here. So it's better to stay on the equator. Sorry. The longitude is just to move along the longitude of the planet. And if you want to orientate correctly the planet, so when you want to export portion of the terrain, you probably prefer to have it looking up, so with the terrain being in the up direction. So you can just check stand upright, and you can reset the orientation here. And with this you have everything in the right orientation, and so when you will export it you will have that correctly oriented. If you don't do that, you will just have the portion of the planet in its place on the planet, I mean. So we will go back to a full planet, and so we will go to 100%, and we will check the relief tab. The relief tab is where you have all your relief, basic relief related things. So you can use an external file for the base of the relief. So if you want to use, for instance, an evolution map that you have for any planet, Mars, the Earth, or whatever, you can just choose a file here with the relief base, and I will open it here in media. I should have some stuff, 8 map. I will check this one, Earth large, and I check also the use input map. And okay, so I have the Earth, see everything here, Europe, Africa, and the US. And you have several parameters like the blur radius. So if you want to blur the input map, because sometimes you have small details that you don't want to see, then you can increase the blur. You can change the input scale, so it will just be how influent is the relief base you've just put there. So if you put 1 here, it will use the full range of values that you have on your file right above. The jitter is just to add some noise. So if you have some flat area where we can see some of this here, you see it's just some lots of places where we have the same 8 elevation. The jitter can just add some random, and if you just add the blur above that, it will improve that a bit. But well, it's just to help with bad files or stuff where you have not enough dynamic on the relief. And the additional noise scale is the extra layer of noise you want to add above the relief base. It can be either positive, so it will be added. So you see here that we are going above the limit, so we should reduce the scale here. So now you can see that I'm adding some noise here, or I can remove some noise. And here also we can go under the limit and go and have some clipping happening here. Okay, I will start with just the regular noise, no external 8 map first. And the basic noise is defined here in the noise section, where you can choose the noise generator. So you have several variations of Perlin, then you have Voronoi, and you have another Voronoi more square-like, well, rock-like. And then you have several variations of these 6 basic noise. So you have the mixed one, which is a blend between regular Perlin noise and Voronoi. And you have the multifractal. The multifractal is more interesting than the regular noise. It adds more variety to the relief. So you have lots of more flat area than some mountains, etc. It's more spreaded than the regular one. And so you have Perlin 1, 2, 3, 4 and the Voronoi as well. And then you have the below, which is basically every octaves of the noise are just put together, and you can see that it makes some little rounded thing. I will maybe go to the shader and increase the amplitude, so you will see what I'm talking about. So you see you have all those little bumps everywhere. So it's really typical of the below purling. And depending on the noise, you will have quite different result. Then you have the below Voronoi, and after you have the hyperfractal, which is kind of like the multifractal we have here, but the results are different. It's just another variation. For the multifractal and hyperfractal, you can use the ramp to tune it correctly. So you see that with this hyperfractal, we start having something quite interesting here. So depending on the scale of the planet you want to make, maybe you can adjust the amplitude to have something quite realistic on the height of the terrain. You can also see that there's a preview of the terrain here. So depending on the parameter you use, for instance, I will modify the roughness. You can see a portion of the terrain here. This portion of the terrain is taken on the equator of the planet, and you can move around the equator here with the left and right. So you can see maybe a section of the planet that you want to see more precisely. You can also have a 3D view, which is quite interesting because you can clearly see the mountains, which is not always obvious from this view from the planet. And so when you change the roughness, you can clearly see what's going on. The rougher the terrain is, the more higher frequency you have on the terrain. So I will have something quite decent here, and with the ramp I can tune that, okay, to have something not going too low nor too high. Okay, and then you can choose the low, medium, and high frequencies intensity of your noise. So if you increase the low frequency, you see that all the more massive mountains are just well amplified or decreased. If you go to 0, you have lots of large mountains in the planet that will look more flat. So you will have only medium and high frequency remaining. So I will put it back to 1 and something. So the same goes on for the medium. So you see that the medium details are increased or decreased, and then with the high frequency you have all the higher details, higher frequency of details that are modified. It's probably more obvious to see that when you have just a portion of the terrain. So if I'm looking over here with highly detailed, okay, I'll remove the stand upright. Okay, highly detailed terrain like here, you will see all the modification going on. So with the high frequency, you see all the small details are moving. I don't know if it's really visible on the... Yeah, okay. If I go to the extreme, you can clearly see what is affected. So if you want to remove all the small noise, then you can reduce the high frequency. Then, well, really play around with these 3 sliders. We'll go back to the full planet here. After that, you have the distortion. The distortion is just to break the alignment, let's say, of the noise. So the distortion will just bend the noise in one direction or the other. It can just add some variety, interesting variety. You see, it's just less regular than before. The ramp is used only for some of the noise. So for this one, for the hyperfractal, it really goes from completely, well, nearly flat terrain to a saturated one. And so it's up to you to just tune and find the correct values for these noises. The seed is the number that is used to as a basic number to create all the other number randomly. So if you change the seed, you change the planet completely. It will use the same tuning of the noise, like the roughness, frequencies, etc. But it's a different one. It's very similar, but it's a different one. So if you want to create, let's say, 5 variation from the same planet, you can just change the seed and you will have something different. It's also quite interesting to just play around with the seed to find some interesting patterns emerging from that. Then you have the scale. The scale is the scale of the noise. So if you reduce the scale, you will have more spreaded noise, and if you increase the scale, you will increase the frequency of the noise. So you have lots of high frequencies here. So also, depending on the scale of the planet you want to create, you will have to adjust the scale. The vertical scale is just to squeeze the planet on one axis. This is really useful when you want to create a gaseous planet, where you want to have lots of things that are stretched around the rotation axis. So for this one, I will just keep it to 1. It's basically to have something asymmetrical, not uniform like the uniform scale you often see on 3D edition software. Then octaves is the number of octaves you will use for the noise. So if you use a very few number, you will not have lots of details on your planet, but it will be much faster to render, to regenerate the planet. So after a certain number, you won't see a lot of difference. It's just because of the scale. Here again, if I go to a smaller part of the terrain, like this one, those patterns are really typical of the purring one I'm using here. If I use another one like purring 2, you see it's not present anymore. So with the octaves here, you can see that increasing the number of octaves can be visible, especially if you increase this value, the high frequency value. You see all these small dots, small holes you have on the planet. It's because of the high frequencies and the number of octaves. So the number of octaves will depend on the scale of the planet you have, on the scale you're using here. So if I decrease the value here, I should probably increase the number of octaves to add some interesting details. And also the portion of the planet you're editing, if you're editing a full planet or just a portion of it. We'll go back to here, full planet, and number of octaves will stay around 8, 9, it's okay. Probably we'll put back the stuff I've made here, the tuning I've made before. Okay, it's better. Then you have the 8 curve. It's quite powerful. I will switch back to the 2D view here. So with this one, you can really tune the curve of the planet you have. So it's the matching between the generation of the noise and the final 8 you will have on your planet. By default, it's just purely linear, but you can use any of the presets here. So you can have this curve, you can have it inverted, you can have a kind of plateau here. So for this noise, it will look quite flat because all the frequency, all the altitude where you have the details is now completely flat. Then you can also have that kind of Gaussian thing. So everything that was low before is still low, everything that is middle is now high, and everything that where every high peaks are now very low again. So that's why you have the kind of it's creased here. So you can really tune it the way you want. We can have the opposite of this. So playing with that is quite maybe quite tricky, but it's very powerful, and you can have also control over your curve by just when you have a square here, highlight it, you can just drag it to modify the curve to have something interesting. You can really have lots of possibilities with that. Alongside this curve, you have also the two sliders here, which is basically the black point and white point. So it's defining where is my lowest and highest altitude on the planet. This is the lowest. So when I increase it, it will just move all the values to a lower range. And the highest, if I decrease it, it will stretch everything up. So you can see that if you go too low for the high value or too high for the low value, you will have clipping. So here you have lots of flat areas because of the clipping. So it's basically better to try to avoid that, especially if it's what you're looking for. But here it's okay. And for the lowest value, you see here it's appearing, so I will just reduce that, and okay, it looks okay. So with that tune, it means that the full range is now used really. So if I'm using a linear one, then I have something interesting. If I have a curved one, then you can see that all the lowest part are now even lower, and the highest part are more rare than before. The plateau here, you have really the deep stuff here, where you can have later, let's say, oceans or lakes, etc. Then you have all this flat area that is that part of the curve, and then you have the mountains here. So if I just tune a bit, okay, so you have a kind of plateau that you can see here. So it's going back to the middle, and then sometimes you have higher value. The higher value is what you have here. So I think that you get the idea now. Okay, so and yes, the two sliders here is to smoothen everything. This one is to have something that will be softer. It's quite interesting, especially if you have some soft clipping issue. So let's say that I reduce the value on purpose here. So you can see, for instance, here, that it's really cut. I mean, the relief is just going down, and then bam, you have a clipping. If you are using this slider, it will soften everything, and it will have a smoother curve. And you can see that here, it's smoother than before. So it's really up to you. If you want to have something that is more rough, then use this one. Otherwise, just use the other, the higher value. And the last slider of that curve editor is just to reduce the dynamic of everything. So if you want to have something that is basically more flat, then you can increase that slider. You can see that here everything is going to the middle. So if I put it to full, then I have everything flat with a value of a middle value for everything on my planet. Okay, I will go back to a regular linear thing, and I will use the full range like before. Okay, and then you have some extra control here if you want to create a continental shelf. So it's basically what we had before with the plateau, except that it's much more accurate than using the slider here, the curve here, because the curve has only 5 points of control, so it's not that accurate. With the shelf here, I will just increase the flattening intensity, and I will reduce the randomization, so you will clearly see what's going on. So if you look at the over here where I have my cursor, the flattening is just increased. It's just everything around that value, which is the shelf level here, it's 0.5, will be flattened. So you are basically creating a kind of S shape for the relief. So if I change the shelf level, you see what's going on here. With if I go higher, I will have my shelf higher, and lower. So it's quite interesting if you want to have lots of flat beach on your planet and stuff like that. And if you want to randomize that, because here basically everything is flat around that level, you can randomize it. So at some place it will not be there, at some other place it will be there. So for instance, you've seen that here it's no like before, but I have some places where I still have that continental shelf. I can change the randomization scale, so you see everything moving on the planet. It's if I want to have lots of high frequency, so that means that I can have a shelf and just right next to it I have something that is more regular. And if I do reduce the scale, then the changes, the randomization will be much more spreaded around. The seed is just to create variation of the dispersion of the random number. And the balance here is, do you want to have lots of continental shelf or lots of regular thing? By default, it's 0, so it's a balance. It's 50-50 between the two, but you can balance that as you want. Okay, so with that, we have already gone through the main parameters for the relief. We will see in the next tutorial how to use the coloring of the relief to have something more interesting than just this dull planet by default.